Ever wondered how one company quietly became the backbone of almost every AI system on the planet? Today on Knowledge Hub, we're breaking down why NVIDIA controls the world's AI, and why no one has been able to catch up. It starts with hardware. NVIDIA's GPUs were originally designed for graphics rendering, but their massively parallel architecture turned out to be almost perfectly suited for artificial intelligence, where neural networks rely on millions, even billions of matrix multiplications happening simultaneously. Unlike CPUs, which excel at low-latency sequential tasks, GPUs are optimized for throughput, allowing thousands of lightweight cores to process data in parallel. As AI models grew deeper and more complex, this architectural advantage became decisive. But hardware alone isn't what built NVIDIA's dominance. The real moat is software, specifically CUDA, NVIDIA's proprietary programming platform that allows developers to harness GPU power for general-purpose computing. Over more than a decade, CUDA has evolved into a massive ecosystem of compilers, drivers, APIs, and highly optimized libraries like CUDA and CUBLAs, all fine-tuned for machine learning workloads. Popular AI frameworks such as PyTorch and TensorFlow are deeply optimized around CUDA, which means researchers get better performance, stability, and tooling on NVIDIA hardware by default. This creates enormous switching costs. Moving away from NVIDIA doesn't just mean buying different chips. It means rewriting kernels, retraining engineers, debugging performance regressions, and often accepting slower training times. Then there's scale and integration. NVIDIA doesn't just sell GPUs, it sells complete AI platforms. From data center accelerators like the A10 and H100 to high-bandwidth memory stacks, ultra-fast interconnects like NVLink and vSwitch, and full rack-scale systems like DGX and HEX, NVIDIA controls the entire AI compute stack. This vertical integration lets them optimize data movement, memory access, and scheduling at every layer, which is critical because modern AI is often bottlenecked by memory bandwidth and communication, not raw compute. On top of that, NVIDIA has spent years co-designing hardware and software together, allowing new architectures to launch already fully supported by mature tools. Competitors often release powerful chips, but without an equivalent software ecosystem, those chips struggle to reach their theoretical performance. Even cloud giants building their own AI accelerators still rely heavily on NVIDIA GPUs, especially for training large models, because training is unforgiving. Small inefficiencies can add weeks of compute time and millions of dollars in cost. And once models are trained on NVIDIA hardware, inference pipelines, optimization tools, and deployment workflows tend to stay within the same ecosystem. So the next time you hear about a new AI chip challenging NVIDIA, remember, NVIDIA's dominance isn't just about faster silicon. It's about owning the ecosystem, the software, the developer mindshare, the infrastructure, and the experience that modern AI depends on, all working together as a single system. That's why catching up isn't one breakthrough away. It would require rebuilding an entire parallel universe of hardware, software, and talent from the ground up. If you have enjoyed learning how the technology shaping our future actually works, make sure you subscribe to Knowledge Hub for more fascinating deep dives. And as always, stay curious.